Alright, so in this video what I wanted to cover is SQL Database Agent with LangGraph. So there are a lot of requests in my channel, like the users are asking how you can build a SQL Database Agent using LangGraph. So I thought about creating this video, but just a disclaimer that this video is like totally dependent on the LangChain tutorial, which is given as a link in this tutorial notebook. So all the credit goes to them. I just using their code to explain how the agent is kind of working in terms of accessing the SQL database, and like given a natural language question, how it can reason out the question, and then it can pull out the data from the database and present the output, right? So all the credit goes to the LangChain tutorial. I'm just running it and explaining it to you. So on a high level, the agent will do several steps. So the steps are given below, which you can see also in your screen. That first it will fetch the available tables from the database. Then it will decide which tables are relevant to the question. So that given the question, what are the tables that are required to answer that question, that it will reason out and select. Then it will fetch the DDL or the data definition language for those selected tables. Then it will generate the query based on the question and the information that is available from the DDL that it has fetched from the DB, right? So then it will do a double check on the query, and it will check for the common mistakes which are related if you are trying to build a SQL query using LLM, right? Then it will kind of execute the query and return the results. And also there is a path which will also check if there are any mistakes while executing the code or not, else it will keep on correcting those mistakes until and unless the query running is successful, right? Then it will formulate a response based on the result, right? So the database that we are using is kind of a digital data set, which you can see here. So where like there are multiple tables which are related, like tracks which are related to artist, and then the songs that has been done by the artist which are present in the album, then the genres, then the employees, customer, invoice, all these tables are present, right? So now let's get back to the code and see how it is working. So first of all, few regular installations like LangGraph, LangChain Community, and LangChain OpenAI. Then just I am initializing the OpenAI key, and after that the LangChain was kind of hosting this database to Google Storage API. So I'm just calling that using this URL, and using the request.get I'm fetching the data from that particular API. And then what I'm doing is I'm just opening a file, and then I'm just writing that to in a database format, right? Else it will throw an error that the response code was invalid and the data was not downloaded successfully, right? So once that is done, then what we are using is we are using the SQL database from LangChain community.utils. So using this SQL database tool, what we can do is we can use a URI, which is kind of a SQLite in-memory database, and based on that we can create connection and like fire queries on top of the database. So you can see what we have done is we just run it for a sample query, like select db.run. Then we written the query, which is like select star from artist and limiting the results to top 10, right? Or just simple 10 records from the database. Now you can see like the data is coming in this format, right? So after that we can start building the components and the tools for our LangGraph agent. So at first what we are doing is we are creating a function which will create a tool node with a fallback to handle the errors, and that errors will be propagated to the agent, right? So it is kind of converting the function or the tool to a LangGraph tool node, and then if there are certain errors, so it will throw back those error to the agent to fix those errors, right? So then we have another function which is def. We are creating this using this def handle tool error, so which is nothing but it will see if there are any error messages present in the state messages, and if there are any errors that are present in the state messages, then it will kind of return the message using that using a string that please fix your mistakes, right? So after that, what we will do is we will initialize the SQL database toolkit. So using those toolkit, we will create two set of tools. One of them is like list tables tool, and another is a get schema tool, right? So we are kind of looping through the tool that are present inside this toolkit, and we are only using the SQL DB list tables and also the SQL DB schema. So what it will happen is using the list tables tool, what you can see is we are just fetching all the tables that are present in this database schema, and then what we are doing is we are doing this get schema tool dot invoke, and we are passing one of the table name which is artist, and we can see like it is giving you back the DDL and also first three records from the uh, for that from that table, right? So what enable for the agent to do is it will give the agent the DDL of the tables through which it will get to know like what are the data types, what are the column names, and all those table related details, and also it's showing like first three records, which also it will help the agent to formulate the query, right? So one of them is like fetching all the tables that are present, and the other one is like if you are passing a particular table name, then it will give the schema details for that, right? So after that, what we are doing is we are creating a DB query tool, so that will execute a SQL query against the tables and get back the results, right? And if the query is not correct, then it will come back with an error message. With that error message will be returned, and if any error is returned, then it will try to rewrite the query and check the query, and it will keep on trying it until and unless the query is correct, right? So you can see like using the DB toolkit, we are trying to get back the result using the query, and then if the query is not present, or the result is not present, or the result is not valid, then it's returning a message that error, query failed, please rewrite your query and try again, right? So then we can like do a sample run on this. So what we are doing is db query tool dot invoke, then we are passing SQL query, and then we are like getting the proper response from this using this db query tool. So in this case, like no error has been found, that's why the result is properly coming, and if the result was not present, then it would have returned a error message, right? So then we are initializing the LLM, and after that what we are doing is we are creating a prompt template, and there we are writing a prompt which is query check system prompt. So there we are asking LLM to play a role, and we are asking LLM to kind of think that the LLM is itself a SQL expert with a strong attention to details, and also we have listed down what are the common mistakes that can happen, so that it is aware of the mistakes, and so that it will not make those mistakes that has been listed down here, right? Then what we are doing is we are creating a chain out of it and binding the tools which is like db query tool to that chain, and then we are passing a particular message to check how the this uh, chain is kind of working. So what we are doing is we are doing query check dot invoke, and we are passing the messages like we are passing a user message like select star from artist and limit the queries to the 5 records, right? So we can see like it's doing a tool call, then it's fetching the arguments, and then it's kind of returning the the tool call result, right? So here like there are no errors that are being that has came up here, so it's just validating the query and returning that there is no message, and it's kind of successfully executing this query. After that we will move to like creating the graph. So at first we are creating the state class, then we are initializing the graph. So the first node that we will have, that we are creating using this first tool call function of Python. So there we are using that SQL DB list tables, which I have already talked about. So we are using that tool, and we are making using this method, we are making that tool call, and also we are giving an ID for this particular tool, right? So then we are creating another function which is model check query, so that so it will use this tool to double check if your query is correct before executing it, right? So it's kind of a safety measure what we are adding in this LangGraph creation. So it will double check the query, and if that is successful, then it will execute the error before running it, right? So then what we are doing is we are adding this first tool call to as the first node, and after that also we are adding the other tools that are present, like the list tables tool, so that we are adding as a node. Then we are also adding the get schema tool node. So as I mentioned, like first it will list down the tables, then it will go to then it will analyze the query and fetch only the relevant tables that are required to answer that query. So using this get schema tool, it will only pick up the tables that are related to the query, right? So then what it will do is it will create another node, so that is model get schema. So and it will using this function like model get schema, and the tool that we have created model get schema, it will invoke the state messages. By passing the state messages, it will try to invoke what are the schema for that particular table, right? So then what we are doing is we are creating a pydantic object which is submit final answer, which is nothing but the final answer to the user question, right? So then what we are doing is we are adding a node for model to generate the query based on the question and schema, right? So we are writing a long prompt where again we are asking the LLM to play a role of SQL expert, and then what we are doing is we are asking LLM to give an input question, output a syntactically correct SQLite query to run, and look for the results of the query and return the answer, right? So then we are kind of giving certain instructions how it should write the query and what are the things it should avoid while writing the queries. So one of them is like do not make any DML statements, right? Which is like data manipulation statement like insert, update, delete. So that we don't want this agent to run. So that's why we are giving a clear instruction in the prompt so that it should avoid writing those type of queries. Uh, then we are creating a chain out of it, and then we are again creating another function which is query gen node. So what it will do is it will check if the final call, the final tool call is submit answer or not. So sometimes the LLM kind of hallucinates and does incorrect tool call, so it will check if the final tool call is submit final answer or not. If that is done, then it will kind of return the tool message, else it will return an error message saying that the wrong tool call was called, please fix your mistakes. So that is a message that is coming from this function, right? So then we are adding the nodes using the functions that we have discussed so far. So we are adding the query gen node, then we are using the model check query, which will kind of do the double checking of the query that has been generated, and then we are adding this execute query, which will just do DB using the DB query tool. It will execute the query, right? So then we are adding a conditional age, so that conditional age will check if the generated query is correct or not. If it is correct, then it will return a string saying that correct query, else it will go to the query gen tool, right, which will again like generate the query and see if there are any errors that are present or not, right? So then we are creating the edges, and once the edges are created, then we will compile the workflow to create an app out of it, and now we can visualize the app that we have created. So it will have the first tool call, so which will kind of list down the tables. Then once the tables are listed down, then it will call this model get schema, so which will only pick up the tables which are related to the query, and then it will call the get schema tool, which will kind of fetch the DDLs that are required to answer the question and also few of the sample records from the table, and then it will pass all those informations that has been fetched using these three nodes to the query gen tool. So query gen tool will have all these details at its disposal, and then it will create a SQL query, and that SQL query will be passed to the correct query, which is again a checker. So that will check if the code that has been generated by the LLM or this agent is correct or not, and once it has verified that, then it will execute the query, and then the control will be passed back to the query gen, and then it will end the execution of the this whole process, right? So then what we are doing is we are passing a query like which sales agent made most sales in 2009, right? So we can see like first it's doing the first tool call, and it's kind of using this SQL list tables. It is fetching all the tables that are present, right? So then it will list those tables. So using you can see like the album, artist, customer, employee, genre, invoice, all the tables that are present in the database that will be fetched, and then it will use this model get schema. So using the model get schema, what it will do is it will fetch the table names that are required to answer that query. So you can see like the employee and invoice is the tables that are required to uh, kind of generate the SQL query for this particular question, right? So then it will do is get schema tool. So it will fetch the DDLs that are related to the tables which are required to answer this question, and also few of the sample records. Now all the database related informations, now it's present for the query gen tool, right? So then the query gen tool will use all this information, and it will try to generate a query, right? So you can see like it has generated a query. Then it's again going back to the query gen tool. So it's kind of checking if there are any mistakes or not. So then you can see like it is returning that I made a mistake in calling the tool. Let me correct the query to find out the which sales agent made the most sales in 2009, right? So then it will call the final answer, the final submit answer tool, and it will return that Jane Peacock is the artist who has made the most sales in 2009, right? So then you can see like the name is also the submit final answer, right? So now the control will go back to the query gen tool, and it will know that it has executed the query successfully, and it has also has the final result to answer the user question, and then it will like finish the execution and come out of this whole loop, right? So this is how you can create a complex SQL database agent using LangGraph. And if the query is much more complicated, you can add like few short examples while generating the query, which will kind of improve the query generation performance, right? So this is all I wanted to discuss in this video. I hope this is helpful for you, and you can use it for your use case, and you can build a SQL database agent using LangGraph, right? So thank you, see you in the next video.